Hello friends, welcome to UGC PG Pathshala. Myself Professor Mary Tahir, Department of Geography, Jamia Millia Islamia will speak on Quantitative Revolution in Geography, which is part of the paper Geographical Thought. This module has been written by my dear colleague Dr. Taruna Bansal, Assistant Professor in Department of Geography in the same university. In this module, the following are the objectives that we are going to study: to understand quantitative revolution in geography, next the developmental process of quantitative revolution in the discipline of geography, next the criticism of quantification in geography. Now, we go on to the introduction of this. In the 1950s and 60s, a revolutionary change described as quantitative revolution occurred in the discipline of geography. It replaced the ideographic approach based on areal differentiations by nomothetic one, which had its root in the search for models and spatial structure and phenomenon. The quantitative revolution laid the basis of geography as a spatial science that dealt with the spatial analysis of phenomena that existed on the earth's surface. In simpler words, it can be said it gave geography a scientific vision through the application of methodology rooted in statistical techniques. Some of the elements of positivism which had previously been not accepted at some point of time were now accepted open-handedly. In the words of Burton, 1963, this school had set out to discover universals, to build models and to establish methods and theoretical basis on which geographical realities could be erected. Traditionally, geography was a discipline that studied and described the surface of the earth, but in due course of time its definition and nature has changed. It has now related in providing accurate, systematic, rational descriptions and explanations of the variations in the geographical phenomenon that occurred over the earth's surface. The most obvious change has occurred due to quantitative revolution that brought changes in the methods and techniques used to explain the geographical phenomenon in a spatial framework. This movement that led to the occurrence of quantitative revolution in geography was initiated by natural scientists, specifically physicists and mathematicians. It expanded and led to change physical sciences, followed by biological sciences. By the late 1960s, it became a feature of most of the social sciences. These included economics, psychology and sociology, though had faint impressions in the disciplines of anthropology or political science, but has not occurred in history. The main objectives of this paradigm in geography were firstly to change the narrative character of the subject, that is geo plus geographic, and make it a scientific discipline. The second objective was to explain and interpret the spatial patterns of geographical phenomena in a logical and objective pattern way. The third objective deals with the use of mathematical and statistical techniques. Next, to make accurate statements, generalizations about location, order. Fifthly, to prepare estimates, principles and laws for testing estimates and estimate the forecast, and lastly, to provide a sound philosophical and theoretical base to geography and to make it a scientific discipline. These objects led to a number of dichotomies within the discipline apart from the quality quantity dichotomy. Now, these included measurement by instrument versus direct sense data, rational analysis versus intuitive perception, cold scientific constructs developed in the laboratories versus rich daily sensed experience from the real world itself, constantly changing phenomena versus discrete cases, nomothetic versus ideographic, to mention a few. If one tries to speak answers to these dichotomies, he gets trapped within them and is unable to understand the movement towards quantification in geography. Thus, to avoid all this, we shall now concentrate on how this movement became part of the discipline and slowly engulfed it in such a manner that it led to the growth and spread of scientific method in geography. Next, we go on to quantitative revolution in geography, how the approaches, the various approaches. Traditionally, geography has been following a discipline. The mainstreams of ideas had their roots in other disciplines. The doctrine of environmental determinism was represented in the writings of Sample, Huntington, Taylor and Ratzel. If he can be considered a determinist, they were busy with the idea of causal relationship and were regularly demanding and looking for laws. A similar mechanical flavor existed in the works of quantifiers. It seems as if geography is re-emerging after it got soaked in ideographic approach, which created a distance between geography and environmental determinism. It seems in some way or the other, the quantitative revolution took geography closer to environmental determinism, especially as this revolution occurred simultaneously with the upsurge of neo-determinism. The quantitative revolution, but natural, was strongly opposed, and the dominance of environmental determinism delayed the process of establishment of the scientific basis that the quantifiers wanted to provide. It was vehemently opposed in United States as determinism had its strongest base there. Still, new techniques were being used and others were being developed as part of the prevailing probabilistic trend in contemporary research. In words of Brownwski, 1959, in simpler terms, statistics replaces the notion of inevitable effect by probable trends. As the revolution progressed, the use and purpose of use of statistical techniques, that is quantification, became more and more indeterministic. In geography, the revolution began in the late 1940s and culminated in the period from 1957 to 1960. Finally, over in 1963, the year Burton wrote his paper. In between these years, it did gain momentum, especially after Ackerman and Schaeffer favored in making geography more theoretical and systematic in nature. Ackerman commented, although the simplified forms of statistical existence have been part of geographic distribution analysis in the past, the discipline is beginning to move towards more complex statistical methods, a completely logical development. Burton further commented that both Hartshorne and Speight also agreed on the use of these techniques in geographical thinking. The reference of Hartshorne in 1959 is being made to a statement which says, to raise thinking above the scientific knowledge level, it is important to establish generic concepts which can be implemented with maximum objectivity and accuracy through quantitative measurements, which can be subjected to comparisons through the mathematical logic. According to Speight, in 1960, in his paper on quantity and quality in geography, published in the Annals of the American Geographers, he seems to somewhat skeptical and quantification in geography. The report of a National Academy of Sciences National Research Council Committee on the Science of Geography 1963 also discussed the influence of quantitative revolution in geography. They stated that geographers believe that correlation of spatial distributions considered both statistically and dynamically may be the keys for understanding the development of life systems, social structures and environmental changes that occur over the earth's surface. In the past, progress was slow and gradual as the number of geographers was less, while the problems were numerous. Moreover, the methods of analyzing these multivariate problems were rigorous. It was only recently that systematic concepts and approaches have been adopted to analyze these multifaceted problems. Next, we go on to the path of the quantitative revolution in the discipline of geography. We are going to understand that. The roots of the revolution were in the following publications, which had this significant influence on the incidence and growth of quantification in geography. These were Newman and Morgenstern's Theory of Games and Economic Behavior, 1944, Wiener's volume on Cybernetics 1948, Human Behavior and the Principle of Least Effect by Ziff 1949, and Stewart's paper entitled Empirical Mathematical Rules Concerning Distribution and Equilibrium of Population 1947. Stewart's paper needs special mention as he puts forward a new way to raise the old geographic questions. The effect of quantification began to be felt immediately in geography. Rather, its rise has been startling in its suddenness. Quantification did increase in geography, and one should accept it as it had a valuable role to play. For example, in 1936, John Carews argued in his paper on corn cultivation and climatic conditions that the methods of relation analysis would be particularly promising tools for geographical investigation. This call was largely ignored. Strahler initiated an excellent petition when he attacked Davis' explanatory and descriptive explanation of geomorphology and supported Gilbert's dynamic quantitative systems. Quantitative revolution in the branches of geomorphology and climatology. Strahler claimed that Gilbert's paper was more apt than Davis' works. Then what was the reason that it was not accepted as a signature post in geomorphology for future work? Rather, it has been forgotten and neglected for nearly 30 years. The answer is with Strahler himself, who gave the opinion that says geomorphology was a part of geography. The physical geographers did not adopt these ideas, rather they followed Davis. Some of the prominent followers of Davis included Douglas Johnson, C. A. Cotton, N. M. Phenomenon, and Lobeck. Strahler finally states these geographers made excellent contribution to descriptive and regional geomorphology and has provided a solid foundation for the study in human geography, but did not lay the base for scientific study within the geographical thinking. This does not mean that prior to Strahler, geographers were not using quantitative techniques in geomorphology. Quam and Woolridge vehemently criticized his views. Quam 1950 stated that mathematical formulae and statistical analysis in geomorphology may result in showing unrealistic picture of reality that might not be accurate and objective. Similarly, Woolridge 1959 criticized Strahler's views and stated that although there is prevalence of a new quasi-mathematical geomorphology, it is unadvisable to use mathematics at a higher level, as these are not apt in explaining geomorphological phenomena. He further stated that whatever the case may be, they will continue to regard Davis as their founder and would criticize all those who do not agree with the methodology of Davis' interpretations of different phenomena occurring over the Earth's surface. It is not that geomorphologists did not adopt quantification. Strahler did find his support in King 1962, who writes that statistical methods are useful for bulk studies and can be well appreciated if used to study complex phenomena and processes that constitute large number of variables or indicators. Although few studies in the branch of geomorphology can apply them, they should be used with great precision so that results are not superficial in nature. Many geomorphologists, in addition to Strahler, like Corley, Dure, McKay, and Wolfman, use quantitative methods, and it seemed that the practice would definitely spread. In the case of climatology, there is little dispute about the use of quantification. This branch of geography wholeheartedly embraced these new statistical techniques to interpret various climatic phenomena. For examples can be cited from the works of Thornwett, Mather, and Green, Bryson, who have successfully implemented quantitative techniques to seek answers for climatic problems, thus silencing their critics. Quantitative revolution in the branches of human and economic geography, how it changed these branches. So far, the biggest struggle for approval of quantification has been in human and economic geography. It is not surprising that in view of the possibilist tradition, it is here that the revolution runs against the ideas of independence and the uncertainty of human behavior. Here, comparisons with physical sciences are useful. Physicists who worked at microscopic level with quanta and energy face similar problem that social scientists face with people. Such parallels, when recognized, are a reason for happiness and not for disappointment. In order to make a reputable place in human society, social science must get direct results in the form of a prediction science that does not need any kind of control or restriction or regiment the person. A social science that distinguishes random behavior at the micro level and is even able to foresee results at this level is nothing but the consequence of quantitative revolution. Several works can be cited which use statistical techniques in a positive manner. Most interestingly, large number of debates took place between scholars that appeared in literature. Burton, 1963. According to him, some of these are worth mentioning. Garrison's and Nelson's debate on service classification of cities, Reynolds Garrison's deliberation on the modest use of quantification in geography, the Spate-Berry argument in economic geography that ends on the agreement that statistics are half of a filled class, the other half is understanding and interpretations. The list is endless, but some of the other debates that need to be mentioned include the contest between Zobler and Mackay on the use of chi-square in regional geography and the dispute of Luckerman and Berry on geographic economic geography. The deliberations were done through professional magazines which got them the much needed attention. The result was the establishment of the Regional Science Association in 1956 that promoted quantification in geography. Moreover, it made quantifiers an essential part of the geographical thinking and gave rise appreciation and approving their work part of the geographical academia. Although most of the literature cites that the revolution is over, it has remained active in several sub-branches of geography, particularly in transport, economic and urban geography. This is evident from the fact that writings with quantitative methods have been regularly published in acclaimed journals in geography, including Annals of the Association of American Geographers, Geographical Analysis, Environment and Planning, the Professional Geographer, Journal of Geographical Systems, Urban Geography and many others. Although quantitative geography is generally perceived as a relatively static research area, it is actually a vibrant, intellectually exciting area in which many new developments are taking place. Has been well explained by Brunston and Charlton and Clark and College, etc. Interestingly, quantification in geography has changed its course in due course of time. It is now an ally of critical geographers. For example, the emphasis has shifted from global generalizations to local levels dealing with local relationships in spatial framework. It has also become sensitive to variables like gender, race, ethnicity, sexuality and age, and even pays attention to processes which shape individuals' spatial behavior. Has been well explained by various scholars such as Kwon, Weber, Boone, etc. Quantitative research is still dominant in the fields of transport, economic and urban geography in the writings of Preston, Rigby, Plummer, Taylor, Swan, Kwan, Bergman, Shepard and Plummer. In this regard, Kwan and Schwann are of opinion that knowledge in statistical methods is essential for decoding and challenging regressive political agendas often supported by numbers and quantitative analysis. Quantitative geography, when incorporated with a critical sensibility and used suitably, can be a powerful device for encouraging progressive social and political change. Now, we go on to the next section that deals with the criticism of quantification in geography. Quantitative revolution was initially propounded to make the discipline of geography a scientific discipline where the validity of the knowledge that was generated was justified according to the principles of positivism. Although many geographers like Plummer and Shepard, Quine have stated and argued that quantitative geography does not necessarily have to be based on the epistemological premises of positivism. Whatever the case may be it has to be understood that when positivist epistemology was adopted, the purpose of geographic research was to seek universally applicable generalizations. The criticism became more prominent as critical geographers started questioning the relevance and value of spatial science in the early 1970s. Now, quantitative geography was labeled as positivist and empirist because it was based on the principles of scientific objectivity, value, neutrality, and the search for universally applicable generalizations. One of the groups that criticized quantification was the group of feminist geographers that was critical of the tendency to draw conclusions based on the principle of universal causality from inferential statistics has been well explained by Schwann and Quine. In 2009, quantification was also criticized for other reasons. For instance, there were those who thought that this method would mislead geography towards a futile course. Some, like Stamp, argued that quantifiers were too busy in sharpening the instrument that they forgot the real purpose of the revolution. Few opponents also commented on the suitability of statistical techniques for all kinds of geography. Their opinion was that these techniques were appropriate for some branches and not the entire geographic paraphernalia. Another group condemned this revolution on a note that there was a confusion of ends and means. In the words of Spade, 1960, it is important to count what can be counted. Another dichotomy lies in classifying and understanding. Classifications should never be mistaken for comprehension. Goodall, 1952, pointed out that it is worth pondering whether he states that quantification methods or statistical techniques are only adjunct to elucidations or descriptions. They can neither provide explanations nor replace them. Therefore, these methods should be observed only as useful tools and not keys to universal knowledge. These criticisms have clearly pointed out that the quantitative methods have several limitations, especially when applied to the study of certain kinds of phenomena. For example, when the purpose is to discover the complex, gendered, racialized or sexualized experiences of individuals or the socio-spatial construction of identities. However, this does not imply that quantification is not in a position to make valuable contributions in the field of geography. The difference lies in the time period. If we talk of 1950s or 1960s, maybe this was not possible. But in contemporary geographic research, it is possible to reconnect the critical geographers with quantification. Another point of deliberation is that within the discipline of geography, several subfields like, for example, transport geography are historically more quantitative in nature than others. This happened because of the influence of allied fields such as civil engineering and neoclassical economics, has been explained by Quine and Schwann. It can be said that the revolution had an early demise. It means that the purpose of the revolution was achieved or not. It is, if seen from the point of view of Burton, 1960, its basic purpose was to make geography more scientific and to develop a body of theory. Discontent with ideographic approach in geography is the root of quantitative revolution. the development of theoretical and model building geography with a nomethetic approach was the expected result. The basic rationale was to develop scientific method, to develop the theory and to test the theory with the prediction, for which the logic of mathematics is the best tool available. Now, we move on to the conclusions of this quantitative revolution in geography. The use of statistical or quantitative techniques is one of the most suitable methods for the development of theory in geography. The revolution can never be over unless it is able to seek answers and aid the theoretical development of the discipline. Moreover, theory development and its testing are the only ways of creating new knowledge and subsequently verifying it. Models are just formalized ways of descriptions that an author has visualized and represented through his arguments and justifications. In geography, quantification brought this revolution, where the ideographic base was replaced by theory building in a nomethetic approach. Geographers started developing theories and created new geography that focused on the philosophy as well as the methods. These scholars were of the view that mere description, mere quantification and mere abstraction were valid to a certain extent, but repeated use of these methods makes one an obscurant. The theoretical geography got its philosophical base in Bund's monograph published in 1962, which identified geometry as the mathematics of space and hence made spatial science the language of new geography. Harvey's explanation in geography 1969 provided a more inclusive channel for the methods and philosophy of new geography. Apart from these scholars, the Department of Geography at Lund University, Sweden became a center for quantitative and theoretical geography under the leadership of Hängestrand and Morell. Hängestrand, although based in Seattle, provided an academic support to the geographers working in this field in the Lund University. To conclude, whichever method one seeks, the purpose of geography is to find answers for questions pertaining to problems of quantity and value. Most of our experiences are qualitative in nature, and when everything is reduced to numbers, most essential attributes are lost. Thus, one needs to maintain a balance, as still new worlds are to be conquered and new contributions to be made. Thank you.